Okay, here we are in ECU test. I have a couple configurations selected here for the multimedia demo. The first is the TBC or test bench configuration, which defines connections to the tools I will use in my demo test case called Verify Navigation and Playback. The first tool I have connected is ADB. This tool has an image port to allow me to take screenshots of my Android device's screen and compare them to reference images. In order to make this connection in ECU test, you will need to install at least the Platform Tools part of the Android SDK and set the path to the ADB executable in your TBC properties. As mentioned before, you can use a virtual device or a real device. My setup for this demo uses a virtual device. I also have an audio port configured in my TBC through the built-in multimedia connection. No additional software is required to run this tool. All you need is an input device and an output device, which you select here in the properties. The other relevant configuration file is the TCF or test configuration. This file configures the ports specified in the TBC and defines test quantities or the signals and values that we want to access during a test run. I won't go much further into the TCF as we are only creating media access points for these two tools in this video. Once media access points are added to the TCF, they will be available in the Actions window under the Media Access tab. Create image or audio steps in a package from here by right-clicking the respective access point and choosing the desired step. In this setup, Android refers to my image port and mic refers to my audio port. As for the jobs I mentioned earlier, those are found under the Job tab here. Moving over to the editor window, let's take a look at the multimedia demo's high-level block steps. These block steps are used to organize the test case in an easily readable way so that someone viewing a test case can quickly get a basic understanding of the procedure. Step by step, this demo will unlock the device, open Google Assistant using a job, send a voice command to open Chrome, navigate to the browser homepage, navigate to a video, turn up the volume by simulating hardware button presses, play the video, record audio from the video and check it for reference audio. Then the video will be paused, the volume will be turned back down, and the device will be locked once again. Sounds simple enough, but there's actually a lot going on here, so I'll expand a few block steps and talk about them before we move on. First, in this Navigate to Home block, there's a job called Execute Shell command, which allows us to utilize the ADB shell in our test cases. In these steps, we're retrieving some properties from the device under test to tell us if the screen is locked or if the screen is on. We also use a job called Start Android package to fire up the Android Assistant app. Then we use text-to-speech in an audio write step to tell the Assistant app to open Google Chrome. Like I mentioned earlier, an audio file or an audio block can be specified here as well in the audio write step. In the Wait for Chrome to Load block, there's a library package called Detect Image Lib. This library package uses an image read step to take a screenshot of the device, and then in a few more steps, it will evaluate whether or not the reference image is found in that overall screenshot. This evaluation can be performed in the step itself by selecting Evaluation, specifying your reference image, and then the tolerances, and that's all you have to do. This library package will then return the coordinates of the found image back to the main package, where it will then be pushed into this tap step. Instead of providing coordinates from a variable, you could also provide raw coordinates or percentages of the screen. And like I mentioned earlier, there are several gestures available. To modify these, all you have to do is drag around the screen to wherever you'd like the gesture to occur. I'd like to show one more step further on in this demo. If we go down to Find Audio Snippet, this is where we have an audio read, which records the video that's playing and then checks it for this snippet. Here you can configure the confidence threshold and use a noise resistant comparison if there is interference or background noise in your recording. The last part of the test case I'd like to take a look at before running the demo is the trace analysis. In the Signal Recordings tab, I've told ecu.test to record my mic audio channel 1 signal for the duration of the test case. Taking that into the trace analysis, I've hooked up my channel 1 audio signal to a generic signal called mic audio. I've also developed some trace analysis that includes plots and checks here. I'm not going to go too deep into the trace analysis. I just want to show a couple of things that might be useful to you for multimedia testing. Firstly, let's look at the Find Audio Snippet template. This works very similarly to the audio read step in the live test case. The main difference is that we can see the exact timestamp where a match occurs in the post-processing here, and we can plot that against the overall audio signal or against other signals. We just need to provide a snippet like before, a threshold of confidence, and whether or not we want to use the noise resistant comparison. There's also a couple output signals here that we can plot as well. Snippet found, match confidence, and active matches, which will be a count at any given point in the recording of how many matches there are. Here, I've defined a trigger based on the results from Find Audio Snippet. So whenever a snippet is found, it just plots that on the overall mic audio signal. And then I've also defined a trigger here that determines if an audio drop has occurred sometime in the test case. The block triggers when no audio is detected and lasts until the audio signal exceeds a very quiet threshold of negative 0.005 to 0.005. The check trigger range template evaluates the length of each trigger found, and I've set it to max out at 3 seconds. Any longer than that, and the range is evaluated to a failure, indicating that there is an audio drop. This check is useful if you want to test the reliability of playback from the device under test. All right, it's finally time to run the demo. Feel free to pause at any time to see how the Android device responds to specific steps in the demo.
Open Google Chrome.
Opening Chrome.
Jobs bei Tracetronic sind so cool, dass alles in Zeitlupe abläuft. Das macht unsere Arbeit spannender.
Okay, so our test case ran successfully. It looks like in the live test case, we have all passes, so that's good to see. Let me just go over a few steps here to show where we used some of the multimedia functionality. So when we were waiting for Chrome to load, we were checking for this reference image, the home icon, and we found it here. You can see in the test report, actually, it's highlighted with a green box. Whenever we find an image, same thing when we were waiting for the home page to load, we were looking for the tracetronic.com logo, and we found it right here on our web page. And then when we were loading the video, we wanted to find that play button, and we found it as well right in the center of the screen there. Lastly, when we played the video, we had no problem finding our audio snippet, so that was a pass as well.